Okay, good morning. My name is Alan Bateman. I'm working in the JDK team in Oracle. And this set of slides and this presentation is about the tests that are in OpenJDK. It's called Meet the OpenJDK Test because it's very much an introduction to the tests that we have in OpenJDK at this point. I want to go through and explain to people where the tests live, what the tests do at a high level, how they're run, and a few other little things that are interesting about the tests. Okay, so we'll get started by talking about where the tests actually live. So the JDK8, and we're talking solely about JDK8 in these slides, consists of 8 repositories, the top-level repository, and then 7 others with the VM libraries and compiler and other code. So when you look at the 8 repositories, you will find that there are tests in only 4 of them. In the hotspot repository, you'll find some tests for hotspot and the VM. In the JDK repository, you'll find the tests for the libraries and APIs and many other things. In the LangTools repository, we have tests for the Java-C compiler and other LangTools APIs. A recent addition to JDK8 is the Nashorn JavaScript engine, and that is in its own repository and comes along with its own tests. So 8 repositories and tests in 4 of those repositories. Clearly there's tests missing from other repositories, and we'll talk about that as we go through the slides. Okay, so here's a quick test inventory just to give folks an idea of what tests are in terms of numbers we have. This snapshot is based on JDK 8 build 82. At the time of this recording, we're up to build 88, so the test numbers have moved on a bit since then. But this is just, it gives you a good snapshot as to where we were at this particular point in time. So in the hotspot repository, there is, for this particular build, 280 tests. In the LangTools repositories, 2,700. JDK repository, 4,850. And with a comment there to point out that there's 50 to 100 excluded tests. And I'll talk about those as to what excluded tests are about later on in the slides. We also have the Nashorn tests, and they have about 750 tests at this time. They're run in a slightly different way via Ant, and we'll talk about how tests run later on. Now, one thing just to say is the test counts on this slide are completely meaningless. What we talk about for test count does not correlate with assertion count or anything like that. We can think of this almost as test source files rather than assertions. So how are the tests organized? So the organization depends on the repository. For the hotspot repository, at the high level, tests are organized by area. So when you look in the test tree, you'll see that there are tests there for the runtime area, for the garbage collector, for the compiler, for the serviceability, and so on. And within that, then, they tend to get organized by bug. The LangTools repositories at a high level is also organized by area. And then under the Java-C tree in particular, which is where the majority of the tests are, they tend to be organized by bugs as well. The JDK repository is at least on first look, it looks a little bit more organized because everything is organized by API package. However, when you look at the detail, you'll actually see that some areas are better organized than others. And sometimes it's not obvious where to put tests. And often we have discussions, and you'll see that on some of the OpenJDK lists periodically, where there's confusion sometimes as to where to put a test because it's not obvious. We'll talk a bit about that later on in the slides. Another thing to say about the tests is they are not pre-compiled. So this might be different from what people are used to seeing before. In the LangTools repository, then you're primarily testing a compiler. So you're compiling from source code into class files. So you don't want the test pre-compiled. In the hotspot and JDK repositories, then we are compiling as we go, and people often wonder what the overhead of that is. It's been measured so many times now. I think it's been concluded for a long time that the compilation overhead during the test execution is not significant. Clearly, there are a lot of tests in those areas you think could be pre-compiled, and that is true. But because the overhead is so insignificant, we don't bother doing that. Okay, so what are the tests written in? Now, this is an interesting thing. So the tests themselves are primarily written in the Java language themselves. Most of the tests are standalone tests, meaning caveman, public static void main tests. They're also typically in the unnamed package. So that's a little bit different maybe from what people are actually used to, and that's this historical reasons for this. But one of the advantages of the tests being standalone and run in is that it makes them really, really easy to debug outside of the test harness, because you don't require to have any kind of setup or configuration to run this test. This is very useful if you need to SSH into a machine, for example, to run a test on the command line. You don't require any setup or any test harness, so that's really, really useful that way. Now, although the tests are standalone, there has been a trend in recent time to make use of libraries. I'll talk a bit about libraries later on in this presentation. And that makes it a little bit more complicated to run the tests, of course, because there's a little bit more setup. We have within the test tree a number of JUnit tests. They're very small, and one of the things that needs to be done at some point is get those converted to something else, test-ng probably. A lot of the newer tests that are going in, particularly in JDK 8, are using the test-ng framework. Both individual tests, these are just individual source files making use of test-ng, and also blocks of tests, particularly the JSR 310, the date and time tests, and also the Lambda tests are all using test-ng, and they're in blocks of tests that are organized in a tree of purely test-ng tests. So more and more we'll see test-ng tests being added to the JDK repository. Now, most of our tests are written in the Java language. We also have a number of shell tests. Shell tests being tests that need to be run via the shell, and the test harness will look after that. But they're tests that typically will do some special setup in the environment before running the test. So if you wanted tests to run with a special ulimit, or you wanted to set up other variables for the test, or set up some particular odd scenario or condition for the test to run in, they will sometimes be written as shell tests. Now, one thing to say, and we've another slide on this later on, is that shell tests have a cost. There's a maintenance cost associated with them. There's also other issues with shell tests that I'll talk about later on. The common thing with all of the tests is that they're run via the JTReg test execution harness, and there's a complement slide deck to this that goes through introducing JTReg, how to write tests, and that someone else will present. Okay, let's talk about the type of tests that are in there. So. One thing to say is that a lot of our tests would be what we would regard as regression tests. And many of those regression tests would be almost stress tests. Now, when I talk about regression tests, what I'm talking about is a test that's testing some particular scenario or bug that has now been fixed. So when we fix a bug anywhere within the JDK, then the default rule is that you must bring a test to actually demonstrate the bug and then prove that the bug has been fixed. So the test will typically set up the conditions to ensure that we're testing for that particular bug, but by having it in the test suite, it ensures that particular bug never comes back. Sometimes it's very, very hard to write a regression test. In particularly writing a regression test that is both reliable and also runs very fast. So sometimes what happens is that you write a test, but because it's so complicated to set up the scenario, or it becomes maybe too fragile to demonstrate that scenario, that sometimes it doesn't make sense to add the test, or sometimes that it comes back to bite you because the test is not reliable going forward. So we have to be pragmatic about these things sometimes, and try not to enforce this rule all of the time. So, for example, if you're testing for a particular crash that takes 48 hours to duplicate, then it's pointless trying to put a test for that into the JDK test, because nobody's going to run that in their local environment, because they just don't have the cycles to be running the tests for that amount of time. Folks want to be able to run tests in minutes, not days. There's other scenarios where it's just way too complicated to set them up. It requires special configuration on the machine that you can't do in an automated way. So you have to be pragmatic sometimes. But the default rule is bring a test when you're fixing a bug, and we call these regression tests. And many of the tests in the JDK repository in particular are what we call regression tests. There also tend to be stress tests in some cases, because the particular bug or issue that they were created to test only arises under very stressful conditions. All feature work then that's going into the JDK, in addition to bug fixes, requires tests. Now, this wasn't always the case in the early days of the JDK tests. The feature work would go into the JDK repository or equivalent without the tests. The tests would go somewhere else. But in recent years, in recent releases is the tests go in with the features. So these would be what people would classically call unit tests. And they're testing the API or the feature or whatever. Now, what I should say is that although they are unit tests, they may not be using a standard test framework like TestNG or JUnit. They're often written in styles that are unique to that particular area, and that's actually one of the interesting or challenging points about the tests in the JDK repository in particular. Is there is varied style in there just because of the breadth of the JDK. Unit tests for newer APIs going in tend to be TestNG based, at least in very recent times. So I've touched on this. The JDK is big and there's a wide variety of tests, and the result is that little frameworks have actually built up in particular areas that tend to help writing tests in particular areas. So there's areas, for example, JDI, the Java Debug Interface, or RMI, where you're trying to test multiple VMs. So you've got some VM running, and you've also got the RMI registry, maybe one or two other processes running as well, or other VMs, I should say. In order to coordinate those, and particularly the startup and shutdown of these tests, frameworks tend to build up around them. So you will see this in many areas of the JDK. So as I said, TestNG is what we've been moving to for some of the newer tests, but many of the existing tests, because they've been there for some time, are not using a standard framework. Okay, so just a few other points about the types of tests. I think for the most part, we could say is the tests are black box tests. They're testing particular APIs, and sometimes they're testing JDK specific APIs, not just Java SE APIs. Sometimes they're testing highly implementation specific APIs, such as Sun.star APIs. Another point about the tests is that they're often testing behavior that is defined well beyond the API specs. Service provider specifics, for example, or very much implementation specific behavior. You'll see that in a lot of the tests. In the hotspot repository, there's starting to appear a number of white box tests. So there's a white box API now for those tests. And the LangTools repository, which has been leading the way in a number of different areas, has both white box and black box testings. And as John Gibbons calls them, gray box tests as well. All right, let's talk a bit about test coverage. Okay, so in I think one of the first slides, I showed you that there was tests in only 4 of the repositories. There's the other 4 where we do not have tests, or areas such as the JAX-P, JAX-WS, Corba repositories. So these are areas where, for historical reasons, the tests were developed elsewhere, other repositories, and didn't migrate into OpenJDK. So that means that if you were to generate test coverage data for the tests that are in OpenJDK, then you may spot some holes. And these are some examples that are very, very obvious. So the XML parsing APIs, the web services APIs, Corba, JNDI, JDBC, and so on. There's a number of these areas where the tests do not exist in OpenJDK. So that creates an opportunity for folks if they want to contribute to tests in those areas. Now, when I say that there are tests, that we don't have tests in OpenJDK for those areas, it's important not to conclude that they are never tested. They are, of course, tested. Oracle and other partners and licensees all, of course, will have tests in these areas as well. It's just they have not been opened and made available in OpenJDK. So areas, with just a couple other points about areas that do have tests is that in general is in terms of test coverage, is the LangTools repository has been setting the bar there in terms of the test coverage and the quality of the tests. In the JDK repository, which is where the APIs and libraries are, then there is some really good coverage in some of the newer API areas where there has been a conscientious effort to develop and unit tests as part of the development. And there's also reasonable coverage in areas that have a lot of regression tests. So there's many areas, many API areas that they're relatively mature, but they didn't have unit tests when they were developed and pushed into the JDK repository. Now, over time, those areas would have obtained a lot of regression tests that cover all the bug fixing that was done over the subsequent years and releases, but they don't have the unit tests that you might expect for those APIs. The hotspot repository has only a small number of tests, and it's very, very clear that if you're touching code in the VM area, then you need a lot of tests. So it's clear that the tests that are in the hotspot repository at the moment are very insufficient if you were working in that area. It would be nice to publish some test coverage data, and there's lots of tools out there that people could actually, if they want to, get more details as to what the exact test coverage is in particular areas. Okay, so how are the tests run? I mentioned in one of the slides earlier that we use the JTReg test harness, and the reasons for that are covered in another presentation. But just to say is that the JTReg existed long before some of the standard test harnesses that are used by people today. So there's historical reasons why we're actually using this OpenJDK specific test runner. But JTReg itself is very, very easy to use when you're used to the command line. It's just a single command to run the tests, and there's a whole slew of options that you can do to configure things, how they're run, and so on, and which tests are run. The hardest part of running tests, and particularly within the JDK repository when there's so many tests, is knowing which tests to run. So if you're working in something in the security area, well, which tests do I run? Do they provide the tests for the APIs that I'm working on, or do I need to be running tests in other areas as well? For example. And when you're working on the JDK code, then it's important that you have some knowledge of where the tests are for that area, so that you can work efficiently and run the tests that are applicable to that area. In addition to running the tests via JTReg, then we also have makefile targets set up in the build. So at the top level, make tests will run tests. Or you can specify particular areas where we have test targets that translate or map to tests for particular areas. And some people working on the JDK do use the makefile targets, but it was primarily set up this way to support build and test systems, and particularly within Oracle, where the build and test system will run the tests via make targets. And the useful thing about that is allows for partitioning of the tests across multiple machines. So when the tests are actually split up into there's 20 or so make targets there, then they can run concurrently on different machines to get through the tests faster. Some of the work around the make targets is still ongoing. There's a bit of cleanup there, I think, to make it a bit more accessible to people and much more obvious as well, so that it's clear which make targets and how and what the right ones are for the area that you're working in. So how long do the tests take? And I'm not going to answer that question in this slide, because it depends very much on how you run the tests and which tests you actually run. Some tests are slower than others. Some areas have a lot more tests and a lot more stress tests that take a long time than other areas. There is a complement to this presentation that will go through JTReg that will cover a lot of the what we call execution modes, and that will explain how to run the tests in more efficiently. The main point though is that if you've got the memory and you've got the right hardware, then you can get through the tests much quicker than might be initially apparent, because the tests can actually be set up to run, at least for most areas, can be set up to run in a whole pool of VMs running on a big machine with lots of memory and lots of cores, and you can get through the tests very, very quickly. And this is very much the most efficient way to get through the tests for the non-client, the non-GUI tests, if you like, because they are set up to be able to run in this mode. Okay, now this is an interesting topic. How stable are the tests? Well, the goal is very simple. All tests should pass on all platforms all of the time. And in the case of the LangTools tests, which is Java C, Java H, and so on, the LangTools APIs, then the tests for those areas have a very good reputation, and they usually meet this goal. They always pass, and which is really, really good. It's less so in the JDK repository, where most of the tests live, and the reason for that is that we have a long-standing issue with tests that fail intermittently, and that might sound scary when you hear it first, but when we go through the reasons for that, it may become a little bit clearer. So the JDK is very, very broad. We have APIs covering a huge number of areas. And one reason that tests can fail periodically is because they're just overly sensitive to the machine configuration. The networking test is an area there that I would point out that is really, really sensitive. So there's some wacky networking configurations set up, and it causes tests to fail because interfaces are plumbed with strange addresses, or there's some other configuration related to DNS or proxies, or any number of other things can cause tests to fail. It's really, really hard to develop tests in that area that are robust enough to be able to detect that they've got some strange configuration. And so that's just one example. And we've this kind of thing all over the JDK. It's really, really hard sometimes to write tests that have a lot of concurrency in there, and if bugs can slip into the test, and they only surface on specific machines, under specific load, and really, really hard. So you might run a particular test might run several thousand times, might be running for years, and then you get some random failure on some particular machine after some upgrade or adding new hardware or whatever. And it's possibly the first occurrence of a test failure, of a failure with this particular test, and those kind of things can be really, really hard. You often have to go work through whatever is left output of the test and try and figure out why did it fail. In addition, we're not standing on a solid platform. The tests exist along with a changing VM, changing library, changing everything. So everything is moving as these tests are running, and bugs inevitably creep in, especially when you're working on a major release where there's significant changes and a lot of code churn going on. There can be a lot of bugs in the system, if you like, as the release is being developed, and they can cause intermittent failures. We also have operating system bugs. It's not unheard of to have crypto tests failing because the native crypto libraries have a bug, or there can be any number of other reasons, of other operating system bugs that can actually cause problems. We also have potential for interference between tests. So when we talk about execution modes in the other presentation, then often you're running tests in the same VM as the previous test. So rather than starting up a new VM for every test, you're running the tests sequentially in the same VM or in a pool of VMs. What can happen is a test can leave things behind. It can change some global settings that cause problems for tests that run subsequently. Not necessarily the same test, the exact subsequent test. It could be many tests later where the problem actually surfaces. Those kind of problems are very, very hard to find. It's possible to get interference between tests that are running in different VMs. So you've got a pool of VMs running, and something changes. One test changes something on the machine configuration, and it's not properly synchronized with some other tests running in a different VM. Then you can get interference, and those kind of problems are really, really hard to find. It's also possible, and this is totally bizarre, but it is possible in some areas to get interference between tests that are running on completely different machines. One example that we had to track down one time was interference between multicast tests. So in a rack of machines, you've got the networking tests running at the same time, and they're using multicast. And what can happen is that one test can actually receive something that's actually sent by another test on another machine on the network, and it can cause tests to fail. So identifying those problems is really, really hard, and fixing those problems is not as hard as identifying them is where the big issue is. But you can see when you add up all of these type of problems together is with the number of platforms, the amount of times the tests are run, the potential for intermittent test failures is high, and it's a very, very difficult problem. And the good thing is that a lot of progress has been made over the last 2+ years. Those that have been watching the commits to OpenJDK over the last few years will have seen a huge amount of fixes to tests and significant improvements to tests going by. But there's a lot of work to do. One thing that people often describe the process of keeping tests reliable is it's a game of whack-a-mole, and there's no sign of the mole surrendering. There's a lot of other things that people can say about this as well. Some people would actually say the moles are armed, and it is a hard problem. And having more people running the tests and having more people looking at the tests and making them more reliable would go a long way, I think. Okay, moving on to when the tests go bad, and tests do go bad. So we often have to exclude tests, and there's many reasons for this. It may be that fixing a test problem is found, but the fix for it is not imminent. If it can't be fixed in a timely manner, then we sometimes have to exclude tests. It may be that the fix for a particular issue is coming via a different route, so we're waiting for a VM fix to come in, or some other logistical reason like that. Sometimes changes in one area can cause tests in another area, and it may take a bit of time to actually track down what that is. So there's many reasons to exclude tests, and within OpenJDK we use two ways to exclude tests. One is via the @ignore tag. So tests have when they have the @ignore tag, then they're just ignored by JTReg. By default, it marks them as error, but you can pass options in there to get it to not report them as errors. In the JDK repository, then we have a separate mechanism, which is an exclude list. And the reason for that is because the exclude list is more powerful than @ignore. It allows us to exclude tests on a per-platform basis. So we might have a test that's only unreliable or problematic on Windows, so we can exclude it only on that platform until the issue gets fixed. And so at any one point in time, there will be tests that are excluded, and there needs to be an ongoing effort to liberate tests. Liberate tests meaning fixing the issue and removing them from the exclude list. So folks that are watching the commits on JDK8 will see periodically, and it happens almost every week, tests being added and removed from the problem list. So there's constant churn on that. Okay, shell tests. I talked about shell tests earlier on in the presentation and mentioned a few issues, and I just want to mention a few more issues about shell tests now. In general, shell tests, and when we talk about shell tests, I'm typically talking about born shell tests, they're typically slower than equivalent Java tests. In particular, they're slower when you're running in tests in the same VM or in a pool of VMs. And the reason for that is because they're needing to start up a VM per test. So the test harness is running the shell test, and then the shell test itself then will typically spawn or start up one or two VMs. So they're slower because of that additional startup. And they're also a maintenance problem. Every time we add a new platform, we need to modify the shell tests. Folks might remember when we added support for Mac, then there was several hundred shell tests that need to be updated in order to work on the Mac. On Windows, we use Cygwin as the shell, and there's a whole bunch of issues and differences between versions of Cygwin that cause a lot of problems, and it's really hard to keep all of those versions, keep tests working on all those versions at the same time. Sometimes with shell tests, you're not testing what you think you're testing, and that's because the shell tests may not be passing the VM options through consistently. So you might be trying to run the tests with the client VM, but if the VM options aren't being passed through and you're on a service class machine, it may actually be using the server VM rather than the client VM. So it's really hard to diagnose those issues. We fixed several hundred of those in 2012, but it's possible that shell tests have changed since then, and issues like this may have come back. Really hard to diagnose. Shell tests are not always reliable. On many occasions, I've found shell tests that were passing, but when you look at the details in the log, you realize that some intermediate step in the shell script was actually failing. And it's really hard sometimes to write a shell test that is really reliable. So a wonderful opportunity for people is to go in and replace as many of the shell tests as possible. I think long term we need to do this. Great effort has been made in the LangTools repository over the last few months to remove and replace shell tests, and we need to do the same for the JDK repository. One opportunity for someone, if they are interested, is to create a library for the things that shell tests need to do, and write it as a pure Java library. And we have APIs in the platform now, and for several releases, that means that many of the older shell tests can be replaced. Some of the rationale and the reasons for why shell tests were introduced several years ago is because it wasn't possible to do some of these things in pure Java. Now it is possible, so those shell tests can be replaced. Okay, so fixing tests. On the last slide, I talked about replacing shell tests, and in previous slides, I talked about the problem list and our exclude list. And these are opportunities for fixing tests, liberating tests from the exclude list, or replacing tests, or just fixing buggy tests. When you're fixing a test or modifying a test, it's really important to understand what that test was created for. On the top of each test, there are typically two tags in there, an @bug and an @summary tag that have links to useful information. The bug tag is the bug number on bugs.sun.com, where you can actually find out if you can the original issue, and the summary then is a description of what the test is for. Now, sometimes the summary is insufficient to explain what the test is doing, but it provides you at least some crumbs. The really important thing is when fixing a test that you don't change the test so that it's no longer testing what it was designed to test. It's really, really easy to go in and modify a test, and it no longer tests what it was originally designed for. So you've got to watch out for that. Okay, so a couple other points just to say about tests is when we fix tests or we add new tests, then they regularly need time to bed in. Sometimes when tests are changed or new tests are added, it could be a few days or a few weeks before you realize, oh, this test actually fails only on Linux and only under certain conditions. I never spotted that in my own environment before I pushed the test, but now I understand why. So there can be a whole bunch of reasons that tests fail. So often for tests, particularly tests that are actually exercising APIs or features that have platform or operating system specific implementations then are sensitive to certain configuration, you need to test them on a wide variety of platforms before you push them, just because they may cause problems later on. Okay, so when adding new tests, so I talked about it earlier in the slide, we add new tests when we're adding new features, we add new tests when we're fixing bugs. The rule is that when you're changing something, adding or fixing something, then you try to include tests that have coverage for the area that you're that you're changing. Sometimes it's not possible. I think I mentioned earlier on about fixing a bug that takes 48 hours to reproduce. It wouldn't make sense to include an automated test for that. That's something for elsewhere. When you're adding tests, and just be aware that there may be tests for this area already. So it may actually be better in some cases to add additional coverage to an existing test rather than duplicating and writing completely new tests. It's important when adding and modifying or adding tests that they be code reviewed to the same standard as the JDK changes. So folks that are watching the OpenJDK lists will see that when we're changing something, we have a code review, we're discussing the changes on the mailing lists, and the same quality of review is required for the tests in order to keep the tests high quality. And high quality tests mean a high quality JDK. Okay, so where do you discuss test issues? So when tests tend to be associated with the area that the test was created for. So you're changing something in the libraries area, then the best mailing list to use for that is the core libs dev. You're changing core libs dev mailing list. Changing something in the security area, you copy the security dev mailing list and so on. So typically you're using the mailing list for the area where the test belongs. There is also in OpenJDK a general quality mailing list called the quality discuss list. This has been there since the beginning of OpenJDK, but at this point the number of subscribers is low, and that needs to increase with a lot more interest in the community on quality. Right, so where do we go? Where are we now? Well, clearly from the slides is that the tests that we have in OpenJDK are not sufficient. in the area of unit tests, for example, is unit tests seem to, are not do not exist for many areas. They tend to be only in areas in more recent, because that's just historical reasons for that. But there's also a lot of other tests that are not present in OpenJDK. Folks that are testing out the build typically want to be able to do smoke tests after their build to give them at least some assurance that build is successful and they haven't broken anything significantly. And so smoke tests would be clearly something that would be interesting to add. We don't have a repository in OpenJDK for performance tests or micro benchmarks. We do have performance tests that people add into the JDK test tree that are not run automatically. But it would be nice if there was some place to push micro benchmarks in particular, because there's always performance fixes and performance changes going on, and we don't want to regress there. There isn't big stress tests or long running basher tests in OpenJDK. That's a whole big other area that could do with attention. And there's also many areas that do not have tests. I highlighted a couple of those, more obvious ones. Another thing is that OpenJDK doesn't yet have a community focused on quality, and we need to change that. We need to build up a lot more interest in the quality of the quality side of the JDK, so that more people can actually contribute to that. Another thing, and this is really important, is that irrespective of any tests that we have in OpenJDK or in Oracle's test suite or other companies' test suites, is that often the best tests are not unit tests for the JDK themselves, but rather real-world applications and libraries, and often folks testing out preview builds or doing builds themselves and running the tests for their own application or library, they're often the best tests. And bug reports, timely bug reports, I should say, are often much more valuable than contributing bug fixes themselves. And because a timely bug report or a good bug report means that to the right mailing list or into the bug database or whatever, means that folks can see it, and folks that are experts in that particular area can identify and fix the issue in a timely manner. Okay, so this is the end of the presentation. It was intended to give people an overview of the tests in OpenJDK and how those tests are run, the type of tests, and so on. If folks have questions and are interested in this topic, then please follow up on the Quality Discuss OpenJDK list. Okay, goodbye for now.